All right, so I'll be talking about the Zephyr Bluetooth controller support and Bluetooth controller implementation in terms of open source is a fairly unique thing, so I hope you'll find it interesting. Before I get into the actual details, I have to give you a short lesson on Bluetooth architecture, so you'll understand exactly what I'm talking about. If you take your typical PC or a mobile phone, you will have the Bluetooth functionality split across two different chips there. You will have the Bluetooth, so-called Bluetooth controller on a dedicated chip, and you will have your host operating system like Android or Linux on your PC or Windows or Mac implementing the Bluetooth host part. In between these two layers, there's something called HCI, the host controller interface. And this is a well-standardized protocol that's part of the Bluetooth core specification. The only thing that differentiates this is the actual physical transport that's happening there. So you could have pretty much all PCs, all laptops, they are using USB for this. So you have the host talking USB to the Bluetooth controller. Most phones, on the other hand, they have a UART between the host operating system and the Bluetooth radio. Now, as far as the Bluetooth host is concerned, we've had, ever since Bluetooth has been around, we've had an open source implementation for this. But the controller part, that was something that was always closed. There hasn't been any open implementations of that. The most important protocol layer I should mention is called the link layer that sits in the Bluetooth controller. So 2 years ago, we were at this situation as I just mentioned. So there was no open source implementations of Bluetooth controllers. Then what happened was that an RTOS called MeeGo, they came out in early 2016 with support for Nordic Semiconductors Bluetooth controllers or MCUs. And we had already announced the Zephyr project at this point, and we were actually very quick to write an application for MeeGo that you could combine together with Zephyr, because Intel, for example, has the Arduino 101 board, which has Nordic's radio there and then an Intel Quark processor. So we actually used MeeGo adopted the MeeGo Bluetooth controller support as soon as it was out and put it on the Bluetooth controller on the Arduino 101, and then we ran the Zephyr host on the Quark processor. What happened a little bit later, the same year, is that Nordic Semiconductor themselves approached the Zephyr project, saying that hey, they have their own Bluetooth controller implementation, and they would like to contribute it to the project. So that was great. It was exactly kind of the missing piece that we didn't have in Zephyr, but this other RTOS MeeGo had. And we ended up working together for several months with Nordic to clean up the code that they had, and eventually we got it merged as part of the Zephyr project. And they're actually heavily investing in the implementation there since then, and implementing the latest features of the latest specifications. So as of today, we have the very latest Bluetooth specification supported, Bluetooth 5.0. Just to compare, most PCs and phones, they don't support 5.0 yet. You are typically at 4.0, 4.1, 4.2. But with Zephyr, you can actually create a Bluetooth controller with the very latest Bluetooth specification. It was Zephyr 1.6 where it was introduced. We are at 1.9 now, so it's like several releases ago. And in addition to being the very latest Bluetooth specification, it's actually very flexible. Common limitation of Bluetooth controllers is that when they are in slave role, they can only support a single connection. The controller support that we got from Nordic, you can do as many connections as the available runtime memory basically allows for tracking the different connection contexts. Another limiting factor, of course, is the airtime. So what kind of connection parameters you have, how much time the different connections require for themselves. Nordic actually did a full Bluetooth qualification of this. It was last week that they got the qualification listing. So you can make a certified product now with the Zephyr Bluetooth controller. You still need to qualify the host stack separately, which is a matter of running the test cases. We run them periodically, so you shouldn't get any issues. But the Bluetooth controller part is something that you can just refer to Nordic's qualification listing if you want to make a product out of this. Since Nordic was the company that contributed this originally, it naturally started off only supporting Nordic radios. That said, the design is such that there is an abstraction there for what the radio interface is. So in theory, it can support other radios as well. And there are a couple of ongoing efforts to bring other radios to be supported. None of these are upstream, but I think you will see them fairly soon. And the interface, of course, that the controller exposes is HCI. As I mentioned there in the first slide, that sits between the controller and the host. Now, whenever you have a product where you have the controller and the host running on the same CPU in the same address space, the Bluetooth specification doesn't require you to have HCI. But because that's what we use in Zephyr anyway, if you want to talk over a physical transport to another controller, it was the most natural thing to choose for the host layers and the controller to talk to each other, even though they're sitting in the same address space, even though there's no physical transport as such. And you can actually build Zephyr in different configurations depending on what you want to do with the Bluetooth controller and the Bluetooth host. So you could have your controller only build. This could be useful, for example, if you want to use your Linux PC BlueZ as the Bluetooth host stack, and then have Zephyr running on the controller. Nordic has this nice small nRF51 USB dongles that you can put on just the Zephyr on and plug it into your laptop and use it then from the laptop's host OS. The Zephyr Bluetooth stack, you can build only the host, in which case it requires an HCI driver for a physical HCI transport, like UART, for example, and then the controller will sit on another chip. An example of this is the Arduino 101, where you have the Quark running Zephyr host stack, and then you have an nRF51 running the Zephyr controller, and they talk to each other over UART. And then, as I mentioned earlier, you can have them running in a single chip. So you could do this right now with any Nordic controller, the nRF51, and then they have the newer one, the nRF52. For those curious, the nRF51 is a Cortex M0-based controller. They come in 16 kilobyte and 32 kilobyte variants. You can fit the full Zephyr stack on both of those, or only the controller if you choose so. And then nRF52 is a Cortex M4 based, where they have the RAM starting from 32 kilobytes going up to I think 64. Maybe they even have a 128 kilobyte one, and they have more flash there as well. Since we have our own controller implementation now that's fully open source, we can do many things which we have never been able to do before with controllers with a closed source implementation, where we can't tweak the internals of the controller. And one of the kind of pain points with the standard HCI is that if you have a solution where the host sits somewhere different, and you don't want to have the controller pre-programmed with a fixed public address, there's no way to do that with standard HCI. So we actually already have defined an extension to HCI where you can tell the controller that use this public address. Another thing is all Nordic chips, they come with registers which have so-called static random address, which is kind of like a public address, except it doesn't have to follow the stringent company-specific address spaces. But there's been no way to use that from the host side because there's no standard HCI command to get actually the address from the controller, so that the host can then choose to program it and tell the controller to use it. So that's another extension we're doing. For Bluetooth Mesh, as I mentioned in my earlier mesh talk, the standard HCI doesn't let you do as tight timings as the mesh specification would allow you to do. So you would either need to have a single chip system with no HCI there, so you can do exactly what you want, or what we are doing is we are extending with a couple of vendor-specific HCI commands where you can get exactly the tightest possible mesh friendship timings that you can have. One feature which the controller doesn't yet have from Bluetooth 5 is advertising extensions. It's an optional feature, so we can still say that the controller is Bluetooth 5. That's something that should be showing up, I think, in the next 2-3 months or so. And of course, what the open source implementation allows us to do, which we haven't been able to do before, is we can prototype features which are not yet public, which we cannot find actual Bluetooth controllers for. We can implement that ourselves in our own controller, and we can make sure that we have the support ready by the time the new specifications come out. So there are also some nice use cases that having an open source controller opens up to us. And that's it for the presentation. Let's go with the questions.
Okay, I see the first one.
I was looking for a way to play with Bluetooth 5.0.
Yep.
And it seems like Nordic boards are the best for development.
I would say so, yes. Especially since it's the only radio that Zephyr, upstream Zephyr right now supports. Yeah. And it is very good, the support that we have there.
Mm-hmm. And you develop using them?
Yes.
Okay.
Thank you. Next question.
So it's probably a bit stupid question, but anyway, so would it be possible, or probably it's possible for now, to manage Bluetooth mesh from some Linux or host device? Because I guess if I have many devices, I would better know which device, what would be the graph between this. Or probably I could implement some mesh management protocol on top of. What do you think about this use case? Probably it's not.
It's not a control question; it's a mesh question, but I can try to answer it. So yeah, absolutely, you can do. You could have. I could imagine that you could do maybe a web service for that device that is interfacing with the mesh network, that you can then from a web browser, for example, go and see.
Is it possible for now or not?
So you would want to wait for the native mesh support for Linux if you want to do this with Linux, this kind of solution. Because at the moment you can do that, but it's limited to configuring and managing mesh proxies, GATT proxies, so it wouldn't be the native mesh network. So in a few months it will be possible to do this with Linux. You could do it with Zephyr as well, because we have GATT proxy support in Zephyr. So you just need a Zephyr board with sufficient memory to run the full networking stack, the IP stack, and HTTP server there, something like that. You could absolutely do it with that as well. As long as you have, you couldn't do it with the 16 kilobytes of RAM, but you could do it with maybe 32, definitely with 64. You could do that.
Thank you.
Yeah.
Thank you. One more.
What should I do to avoid like split mesh situation when half of the mesh somehow, I don't know, one edge broke and they don't communicate? Is there a way to how it can rebuild itself?
It's not, Bluetooth mesh isn't routing based. the nodes are just blindly broadcasting. So the way that you protect against something like that is to have redundant relays, so that the packets can get to the same node through different paths. So it doesn't somehow intelligently heal itself. You just have some redundancy there, which does a little bit of unnecessary saturation of the bandwidth available. But mesh can handle that to some extent, as long as you don't have everybody being the relay.
Mm-hmm. Thank you.
Okay. Questions? Okay, I think it's a question to you, Johan and Andrei. What's the best that you receive while this hour? What is the best questions that you received?
There were lots of good questions. It's a tough one to say.
Okay.
Andrei?
Okay, we'll left this undecided. Okay.
But those that did ask questions, we still have a couple of Zephyr stickers here if you want. So.
Okay. Thank you very much.
Thanks.